You are a new admission or you're present in the last class? Have you noted down the last? Did you attend the last class? I don't see the Nokia calculus. Where is the last one? I think she was not present for the last. Because you remember we started with the second unit. Measurement of length using position vectors. Yes. So I had explained for screw gauge also. Okay, already explained. How come there was last lecture before the previous?
I already done before lecture, so I further.
So you have kept 11 pages. Fine. Okay, so let's get started. The last class I told you about how to take measurements, right? So, measurement of length basically. We are two instruments using vernier calipers. And screw gauge. Okay. So how do we measure before measuring length, right? We need to know the least count of the device. Correct? So least count of vernier calipers, how much was that? Value of, this is the formula we derived. Value of one main scale division divided by number of divisions on vernier scale. And what value we got? One main scale division was 0.1 centimeter divided by 10. So this gave us 0.01 centimeter. Okay. And how did we calculate the least count of screw gauge? Let's see on screw gauge. This also I told you.
Yes.
H upon number of divisions on circular scale. Right? Now, if you look at pitch on one turn of the circular scale, you get 1 millimeter, that is 0.1 centimeter. This divided by 1 millimeter is 0.1. Same like this. So 1 millimeter is 0.1 centimeter. Divided by, generally on a circular scale you have operative units. So this is about 0.001. Okay. So what is a least count? It is the smallest measurable length by the given instrument. So vernier calipers can measure 1/10 of a centimeter, right? Sorry, 1/100th of a centimeter, whereas screw gauge can measure 1,000th of a centimeter. Okay. Meaning if you make 100 parts of centimeter, one part is least count of vernier calipers. Make 1000 part in a centimeter, one part is the smallest length, which are screw gauge. Yes.
हाँ खींच पूरा दिखे नहीं वो भी चाहिए छोटे में
क्या चीज है
ये माइक का
अच्छा ठीक है अब लेंथ क्या हाउ डू यू टेक मेजरमेंट्स आई टोल्ड यू measured value to measured value must be equal to what? Observed value, right? Minus 0. Minus 0. Okay. And what was the observed value? Which is equal to so which is main scale reading plus vernier scale reading minus 0. Okay, so this is in case of vernier calipers. In case of screw gauge or main scale reading plus circular scale reading minus 0. Okay, this is how you do it. Let's understand this. सबसे पहले we will see the zero error form. Did I tell you how to calculate main scale reading? How to measure? Did I tell you all this? With the help of the book example? No, so we are to do this, right? So illustration. So we using yes. So in your textbook, I think you have an example. This example is given on page 19. Therefore, figure 1.11. So what is this figure? You don't have a textbook? Sure. Why don't you join us? Same page you can refer. This is of screw. Figure 1.6. Page 15. See the diagram. What is shown here? You have two scales shown here. Right. So vernier scale is below. So vernier scale can slide over main scale, you know that, right? So what is the main scale reading? It is before the zero of the vernier scale. So where is the zero where the vernier scale pointing? It is after 5.123. Main scale reading is 5.2. Main scale 5.3 centimeter. We did this, already did, right? Then what is the vernier scale reading? That's why you said you have to do the zero error, right? Okay. So anyway, let's do the vernier scale reading also. This is the coinciding division, which is the sixth division. So what is vernier scale reading? Coinciding division into least count. So 6 into 0.01, which is 0.06. What is the observed reading?
5.8 plus 5.86.
Yes, so the observed value is 5.36. This here now. This is the case when there is no zero error, right? Now let's calculate the positive zero error. For this, we refer to diagram 1.4. Okay. This diagram will help you understand how to calculate positive zero error. First, what is the meaning of positive zero error? When you close the jaws of the vernier calipers without anything into it, then the zero of the vernier should match with the zero of main scale, right? But you can see here, the zero of vernier is actually ending to the right of the zero of main scale. Meaning, even though the jaws are closed, still there is some small length, the gap between the two zeros, that is the length. So positive zero error means whenever you take the measurement, every time the instrument will show you more length than the true length. Okay? So this excess length has to be subtracted. That is why you have to minus the zero error. Okay? So positive zero error is shown in figure 0.4. In this case, the zero of vernier calipers lies ahead of zero of main scale. Okay, that is the instrument with positive zero error will always record length greater than actual. Greater than actual. Okay, so therefore it has to be subtracted from the observed value. So how to find out? Same method, because see which reading on the vernier scale is matching, right? So it is the coinciding division is 6th. So that multiplied by least count with a plus sign, right? So zero error is equal to 6 into 0.0. 0.06. Okay, so what is the zero correction? Therefore, right now that will be vernier calipers example. So therefore, so value is equal to observed value was how much? 36. And zero error is 0.06. 5.2. This is the correct value. Let's check what is negative zero error. So negative zero error mein you have to refer which figure 1.5. So now when the jaws are closed, the zero lies to the left of main scale, right? This case. Zero of scale lies before,
Yes.
before the zero of main scale. Right? That is every measured value measurement record value less than the actual one. So while correcting, what you will do, we'll have to add it. So to add it, what we will do? Minus Z. So zero error we record with a negative sign. So it will get added. So how to find negative error? Negative zero error. This is now which is the matching thing? 6 only, right? So here, first you write minus sign. Then you write total number of division. Total number of division on vernier scale is 10. Then which is the coinciding division? 6. Then into this now. Okay, so this is minus 4 into 0.01. Minus 0.04. Okay, so zero correction. Correction. What's the value? 5.36 minus 0.04. It will get added, right? Because measured value is always less, so it has to increase. So 5.4. Got it? So this is all about vernier scale and how to take measurements with zero error correction, right? Next is same thing for. So are you writing it? You write it. You better write this down. You better to understand. Refer to the diagram of the book. Have you written it down? So shall I erase it? Next is same concept, right? Just instead of horizontal vernier scale, you now have circular scale, right? So vernier is replaced with the circular scale. And the number of divisions are like 100. Okay, it could be more than 100 also, but minimum they are working with 100 divisions. So this diagram to refer 1.119. That's what we started with, right? What is diagram 1.11 on page? On page 19. Okay. So look at it. So what is the main scale reading? Again, first we'll calculate the observed value, assuming you don't have zero error. So this is the case without zero error, right? So the measured value will be equal to observed value in this case, which is how much? Only this much. Sorry, because our CSR. Okay, this formula we are using was two. So this is the true value. Main scale reading plus circular scale reading. Suppose the main scale reading. So main scale reading is whatever is shown on the main scale. Okay. So what is shown? 1.2 millimeter, which is 0.2 centimeter. Right? 0.2 centimeter. Okay, what is circular scale reading? Again, it is the circular scale division which is matching with the baseline. So which is matching with the baseline? 56 into least count of the screw gauge. What is the least count of screw gauge? Okay. So which is how much? 0.056. Okay. So now, circular scale reading is equal to coinciding division of the circular scale with baseline into is count of screw gauge. Okay, this is how you have got this. Okay. So now what is the true value? The true value without zero error. MSR was 0.2 plus CSR was 0.056. How much is this? 0.56. So this is the observed value, which is same as without zero error, it is same as true value. That's this. Let's convert the positive zero error. So which diagram will you remember in this case? figure 1.9 on page 17. Okay. So how to find out zero error? Coinciding division into least count, right? So it is the fifth division which is coinciding, right? With the baseline. Can you see? Fifth is coinciding with the baseline. So positive 5 into least count, which is 0.01. 0.00. So how much is this? Yeah. So with positive zero error correction for no value, with positive zero error correction, how much is it? So true value minus plus 0.1. How much it is? Yes. Right. Likewise, calculate the negative zero error from the diagram. For negative zero error, 1.10. 880. For this one. So it is showing 95. Now see how to decide whether zero error is positive or negative. When the zero is below the baseline, then it is showing some length that is positive. When the zero is above the baseline, right? वो लिख लो तुम यहाँ. Zero of circular scale lies below base. Then it is positive zero error. When you fully close the screw, right? In this case, zero of circular scale lies above base. This is how you will identify. Okay. When the screw gauge is fully closed, what does it mean fully closed? See, to take measurement, you have to hold the object between these two. So when you totally close it, this will actually touch A. There will be no gap between A and B. B will close or touch with A. Okay? In that situation, these diagrams. Right? In that situation, when the zero is above the baseline, it is negative zero. Okay. So now come to figure 1.10. So how to calculate negative zero error? Same like vernier calipers. So first you will say negative sign. So negative zero error. First negative sign. Then you have to subtract the coinciding division with the total division. Only in negative case you have to do this. You see the coinciding division is 95. Then multiply with least count. Okay, so how much is this? This is minus. And again it is 5. 2 response was 0.001. Still get minus 0.0. Yeah, this is the negative 0. Now subtract from the original value. Original value was, true value was how much? Where is the true value now? This is the true value. So therefore, true value with negative 0 error correction. How much this will be now? This is 0.6. Yes. Which is this? Plus 6 plus 1. 0.6. So in book they have given different diagrams, but now I have combined all of them to give you the true value measurement. So this calculation you may not find in it. Okay, they have only calculated different errors and left it. So with this we are through with unit B of this chapter. Now I want you to go through the examples in this book for next 10 minutes. Okay, so there are 7 examples. Just go through all this, then we'll take up numericals. So you can see this. Solved examples here. Go through first. These are all the by yourself. Yes, you have to ask questions. Here and there. Done? Any issues? Okay, keep the- So now we'll do some numericals from this chapter, from this unit. So is this chapter done in your school? Which, if it is done, then do you face any difficulty, any question? Have you tried all the questions? Some. Okay, so do you have any difficulty? Any question?
For the calculus ones, I can do it well, but it's
Okay.
all the
Screw gauge, you have difficulty. So shall we take one question from screw gauge or two questions from screw gauge and one from market? Okay, let's do that. So now if you have understood all the examples, I doubt you will have any difficulty. Okay. So you tell me which one should I pick up? Go through the exercises. So let's begin with the first one. Say a stopwatch has 10 divisions graduated between 0 and 5 second mark. What is its least count? Try that. So what is the least count of the watch? It is the smallest time which it can measure. Right? So smallest time will correspond to the one division of the clock. Right? How do you do? So what do we do? 0.5, right? How do we get it? See, 10 division of the clock correspond to 5 seconds, right? Therefore, one division of the clock correspond to 5 upon 10. This is equal to how much? 0.5 seconds. Okay. So the smallest division, whatever measurement it can make, that is the least count. Sure. All right. Do question third. Okay, 1 year के ये करो 3, 4, 5, 6. Then we'll go to screw gauge 3, 4, 5, 6. Then you can try it also. Diagram question. You get the third question right? What is question 3? Please count, how do you calculate value of one main scale division divided by number of division on verniers. Okay?
Correct.
You got it? Good. So what is one main scale division? 1 by 20 centimeter, right? It is 1 divided by 20 centimeter. What is number of division on vernier scale? Good. Okay. So just do it. So this is 1 upon 20 into
1/1000.
this is 1 upon 1000. So how many zeros?
0.01.
Results. Okay. This is how you do it. So you have to remember this well. Okay. Next one, try fast. Question 4. Each question should take at least 1-2 minutes, not more than that. So measured value is 1.4 millimeter. The zero error of the vernier calipers is 0.02 centimeter. So plus 0.02 centimeter. Right. So measured value is in millimeter. So either convert this in centimeter or convert this in millimeter. So centimeter to millimeter is 10 millimeters. So this is 0.2 millimeter. Okay. So therefore true value is 1.44, 1.4 minus 0.2. 1.2. Okay, so this is the correct thickness of pencil, 1.2 millimeter. Question 5. As its main scale graduated in millimeter and 10 division on its vernier scale. Okay, so same thing. So find the least count first. So LC is how much? 1 millimeter. As per the given data. When the two jaws are in contact, the zero of vernier scale is ahead of zero of main scale. So it is positive or negative? Huh? Positive, because it is on the right side, right? So it is so it is positive zero. So the third division on the vernier scale coincides with the main scale division. So what is the zero? So it will be positive zero. The third division coinciding into the least count. So it will be plus 0.03. Okay, plus 0.03. Let's do the 16th question, 6th question. The 6th question. The main scale of the vernier scale is vernier calipers is calibrated in millimeter. That means smallest division is 1 millimeter, right? And the 19 division of main scale are equal to 20 divisions on vernier scale. So here what is given? What do you have to find? First you have to find the least count. Least count is equal to 1 millimeter divided by 20. What it will be? 0.05 millimeter. Right? This will be 0.005 centimeter. Okay. This is the least count. Then, in measuring the diameter of the cylinder by this instrument, the main scale reads 35 division. So second, main scale reading is given as 35 division and 35 millimeter. Okay, which means 3.5 centimeter. So this is the main scale reading. Then the fourth division of vernier scale coincides with main scale division. So what is vernier scale reading? The coinciding division into least count, which is 0.005, which is 0.02. Correct? So what is the radius of cylinder? So this is the diameter, right? Therefore, diameter to 3.5 plus 0.02, which is equal to 3.52 centimeters. Therefore, radius is equal to 3.52 divided by 1.76. Right? So you have to be careful. Like, you know that when you measure with the vernier calipers, it is going to measure diameter. But what is asked in the question? Radius. Okay. So you need to be careful. We will do one more last question, which is 8th from vernier calipers. Now you do 8th question. What do you answer? Done? So what is the main scale reading? First, what is the main scale reading? Main scale reading is anything to the left of 0 vernier caliper. So it must be 3.3 centimeter. What is the clear main scale reading? 3.3 centimeter. Now what remains is between 3.3 and the 0 of the vernier. Only that gap has to be calculated. So what is the vernier scale reading? What is the coinciding division? See, sixth division is coinciding as per the diagram. Right? So it will be 6 into the least count, which is 0.01 centimeter. 0.6. So what is the true value? Because there is no zero error given in the question. So that means no zero error. The value is equal to 0. This is equal to MSR plus BS1. How much is this? Is it 3.36 centimeter?
Yes.
So why you are taking time? Acha, you had calculated. No, but don't write the answers directly. Show FSR, VSR, then add them. And if there is any zero error, then you reduce that also. But is there any zero error? No, no zero error. So when no zero error, this is the correct. Okay, let's do now questions on screw gauge. Let's start with question 9. Question on screw gauge. Yes, can you do it?
Yes.
Maybe also. Pitch is given as 0.5 millimeter. Red scale is divided into 100 parts. Least count is pitch upon number of division on circles. Pitch upon 100 in this. 0.5 millimeter. About 100. 0.005 millimeter. This is the least. In centimeter, it will be 0.0005.
Yeah.
Okay. Not necessary. What is the least count? So either you write this or this. Generally, if you write in centimeter, it is better because main scale is in centimeters. Question 10. Good. So now the thimble of a screw gauge is 50 degree. Instead of 100, now it is 50. Spindle advances 1 millimeter when screw is turned through 2 revolutions. So what is the pitch now? Pitch is the advancement in screw when it is rotated by one turn, not two turns, right? By one rotation. So here, two revolutions correspond to 1 millimeter. So one revolution correspond to 1/2. So pitch is equal to 1/2 millimeter. Got it? Because two rotation correspond to one, whereas pitch is distance traveled corresponding to one rotation, which is 0.5 millimeter. And 50 degrees. So therefore LC is equal to this is how much? 0.1 divided by 10, 0.01 millimeter. Or 0.001 centimeter. ठीक है, दोनों लिख दो. Millimeter as well as. So what is it? So pitch is this. What is the least count of the screw gauge? So this. So both we calculate. You understood how to calculate pitch? So do 11, question 11 yourself. So you got the least count.
Yes.
So what is the main scale reading? Main scale reading is main scale reads 2 millimeter, right? So what is the main scale reading? 2 millimeter. In centimeter it is 0 point. हाँ तो इतना डर क्यों लग रहा है? No, just 0.2 millimeter divided by 10 is centimeter. Just 0.2 centimeter. Now it says least count you already calculated. It is 0.001 centimeter. So how to calculate the vernier scale reading? The coinciding division, which is 45, into the least count. Huh? 0.045 centimeter. So what is the vernier scale reading? 0.045 centimeter. So 45 into 0.001 is 0.045. Now there's no mention about zero error of the instrument, so it's without any error. So what is the diameter of the wire? It will measure diameter only. Just add main scale reading and vernier scale reading. Got it? Understood also? Chalo, try question 12 also. We'll do 12, 13 and 14. So sleeve is main scale, thimble is circular scale. Least count is already provided. So convert everything into centimeter. Switch off the AC. Okay. Which part you're not getting? When a screw gauge is of least count 0.01. So write down least count is 0.01 millimeter, or in centimeter it will be
0.01.
that is 0.01 millimeter.
0.1.
0. Come on. You have to divide by 10. 0.01 centimeter
1 millimeter.
is
0.01.
0.1 centimeter. See, millimeter to centimeter conversion, how will you get centimeter? 1 millimeter is 0.1 centimeter. So it will be 0.01 centimeter. Then
diameter is
so diameter. So how to find out?
MSR plus CS.
So what is the MSR? The reading on the sleeve is found to be 1 millimeter. So this is MSR. So 1 millimeter is 0.1 centimeter. So right on. MSR is equal to 1 millimeter, which is equal to 0.1 centimeter. So what is VSR?
CSR.
What is CSR? 27th division is found to be matching the baseline. That's what is given. So what is the reading? CSR will be 27 into LC. What is the LC? 0.01 centimeter. So 27 into 0.01 centimeter. So which is equal to 0.027 centimeter. So the first thing, the diameter is equal to MSR plus CSR.
0.127.
So it is 0.1 plus 0.027, which is equal to 127. Right. Second, what is given? Positive zero error is given as plus 0.005 centimeter. So what is the answer with correction? It is observed value of the diameter, which is 0.127 minus 0.005.
But observed value means 0.1 centimeter.
Observed value is the first answer, right? Which is 0.127 centimeter. Now we are doing zero correction. And the zero error is already given in the question. So you just subtract because it is positive zero error.
0.12.
0.12. Got it?
Yes.
So you got a clear idea how to tackle screw gauge questions? Chalo, try 13th and 14th. These two if you try without any help, then you're home. So what is the pitch? It is the distance moved by the screw in one rotation. Got the pitch? So it same like question 10. Absolutely same like question 10. In 2 rotations, it travels 1 millimeter. But what is pitch? 1/2 millimeter. Pitch is the distance traveled by the screw in 1 rotation. So it is how much? 0.5 millimeter. Okay. So 0.5 millimeter. Point 0.5 millimeter. Okay, next. Pitch you found, then the least count. Least count is nothing but 0.5 millimeter divided by 50. Total division is 50. So you'll get 0.01 millimeter. This whole question is in millimeters, so no need to convert it into centimeter. Now the 0 is below the baseline. Is it positive? It's positive. And 4th division of the circular scale is in line with the baseline. It will be 4 into least count 4 into 0.01. So this will be plus 0.04. Was it difficult? All right. Do the remaining 2 questions also. So you will end up doing all the questions on screw rotation. You have 15 questions, right? Read. So what is the pitch? 1 millimeter. Very good. Because it advances by 1 division on main scale and the circular head is rotated once. So it is 1 millimeter. Now the least count, pitch divided by total number of divisions. How many number of divisions are there? Must be 50. Right? Because you see what is shown in the diagram? At the bottom 40. 40 is the bigger mark, okay? The bigger mark. So 40. So 40 to 0 is 10 divisions, right? So it is 0th mark is after full rotation, 0th mark is 50. What is the least count? 1 divided by 50 millimeter, which is 0.02 millimeter. Right. Now, so what is the coincidence? Now you have to find out the diameter of the wire. So for that you need main scale reading and circular scale reading. What is the main scale reading? 4 millimeter, right? Or so answer is in millimeter. So 4 millimeter. That's main scale. What is circular scale reading? Coinciding division into least count. So which division is coinciding? From 0 you count backwards. So 1, 2, 3 means 50 minus 3. So 47th division is coinciding. So 47 into least count. That is the circular. So it is 0.47, right? What is the least count? Oh, 0.02. So 0.02 into 47. Rather 47 into 0.02. What is the least count? Yes. See, what is the main scale? Main scale reading you got as 4 millimeter. What is the circular scale reading?
7 into 0.02.
0.2, the least count, right? In millimeter. This answer also will be in millimeter. So 2 sevens are 40, 1. So 94, right? 0.94 here. Millimeter.
And this R plus CS.
So just add these two.
4.9.
4.94.
Millimeter.
Which is the answer? Right?
Yes.
So are these questions hard? Hard if you don't understand. Once you know the trick, do the question. Do question 15. Did? So what do you have to find out? What should be the number of division? Huh? So pitch is equal to
0.5.
huh?
0.5.
0. No, what is the formula? So pitch is least count is pitch upon number of division. Pitch upon the number of division of circular scale, right? Circular scale. This is what is your least count formula. So just substitute. So least count given is 0.001 millimeter. Okay. Correct up to 0.001 millimeter. That means it is least count, smallest. Pitch given is 0.5. So cross multiply number of divisions. Therefore, number of divisions
0.5.
upon 0.1. So multiply up and down by 1000, you'll get 500. Sorry, 500. So you can multiply up and down by 1000. This 1000 will be cancelled. This will become 500.
Number of divisions on its head will be 5.
Yes, number of circular scale division you have to find out. Such that you get the least count as 0.001 millimeter. Okay.
Yes.
So we have only 1 or 2 minutes before break. So just go through Unit B. Now we have only one part remaining, which we shall cover in the next session. That's after the break, right? It's a 3-hour lecture. So today this chapter is going to go over, and probably we'll get to start the next chapter also. Motion in 1 hour. Yes.
We have made us some readings for school watch.
You what?
We did the readings with school watch in school.
Readings
The wire.
today.
No.
This is the experiment.
Yeah.
Okay. So how was it like? Did it go well?
Yeah. I got 0 error.
You got 0 error.
Yeah.
Means instrument did not have any error. Okay. And
They told us.
what did they ask you to measure? What diameter of wire or something? Okay. So let's meet after the break. Huh? I'm leaving my book also here and that book also. Calculate. Yes, this is our last lecture. So are you experts on taking measurements using vernier calipers and screw gauge? Hmm? Say yes, sir. Okay, with this, we will begin the last part of this chapter, which is measurement of time. Okay, so far we learned about how to take measurements of length. Now, measurement of time. Now, how to measure time? How do we measure time? For length, we require some reference. Between any 2 points, we define, okay, this is 1 meter. What about time? How do we define? So duration. So for that, we need to look for phenomena which repeat itself after fixed duration, like rising of the sun every day. It rises at the same time, right? So the duration between one sunrise to the next sunrise, we call it 1 day. Okay. So for measurement of time, time, we need to take into consideration some phenomena which repeats itself after fixed duration. Right? So we need some phenomena which repeats itself after fixed duration, like such as time duration between consecutive sunrise. ठीक है ना? So this duration between 2 consecutive sunrises is called as 1 day. It's called one solar day. ठीक है? So now we know that This event from one sunrise to next sunrise is 1 day. Now we divide it in 24 equal parts. Right? So 1 day divided by 24. Whatever time duration comes, we call that 1 hour. Okay? When we divide 1 hour into 60 equal parts, we call that as 1 minute. Isn't it? When we divide 1 minute into 60 equal parts, we call that as 1 second. Okay? So this is how in old days we used to label time as 1 second. Right? But now what we do? We have clocks. So clocks. We have clocks. Use clocks to measure time. So how do clock function? So we have something called as pendulum. Right? What is a pendulum? This is a pendulum, right? So it is going to and fro, right? Now if you take a clock and measure its duration, for example, through a stopwatch, you will find that during oscillation, going from one end to other end, and again going to the next end, this is one oscillation. The time taken to complete one oscillation is same. Okay? So we will then use this kind of a thing to measure time. This is an event. Okay? So this is like let's say I start from here. Pendulum, let us say this is our simple pendulum. So in short, why are we studying about pendulum? Because it helps us measure time, right? Because pendulum is something like hanging from the ceiling. What is hanging from the ceiling? This metallic ball. This we call metallic ball. Okay, and it is tied with a string of length L. Okay, and there is this small length, which is radius of the ball. Length of the string plus length of the radius of the ball. This makes length of the pendulum. Right? The length of the pendulum. Am I right? Is it L is equal to L plus R? Or is it the other way around? This is capital L and L. Okay, this is the length of the pendulum, capital L. So length of L is length of the thread plus radius of the ball. Okay, center of this. So we can set this into oscillation, right? So what we can do is we can take the ball to one side, stay here, and then release it. So when you release it, it will not stop here. It will go further. Right? What you see is it makes to and fro motion. This is one side is to, and the other side is fro. Okay, so this is called to and fro. This is to. One side is to, the other side is fro. So from one end, again coming back to the same end from where it started, that is one oscillation. Okay. So what is one oscillation? Is 1, 2, and fro. The form. This is called one oscillation. Or it is also called one cycle. Also called it is observed that when you conduct the experiment, right, this one oscillation time, okay, is always same. It is called time period, right? So what is time period? Time taken to complete one oscillation is called time period. Its symbol is capital U. These are the terms associated with time. Then there is something called as frequency. Frequency of oscillation. It is the number of oscillations completed in unit time or 1 second. There is number of oscillations. Yes. Right? So now relation between E and F. E and F. So since T seconds, T seconds, T second correspond to one oscillation, isn't it? Okay? T second correspond to just one oscillation. Therefore, 1 second correspond to how many oscillations? 1 by T oscillation. Right? But this is nothing but frequency because it is the number of oscillation in 1 second. Therefore, frequency F is equal to 1 by T. The number of oscillations taking place in 1 second is 1 by T. So it must be frequency, right? Then the unit of frequency is hertz. These many hertz. With the unit of Okay, so we know oscillation, we know time period, we know frequency. Now we must know what is amplitude. A or any symbol. Generally, A is reserved for acceleration, so we will go with capital. What is amplitude? See, this is amplitude. It is the displacement from the mean position to extreme position. So this is the rest or mean position. Right? It is maximum displacement of the ball on either side from its yes mean or rest. Okay. These are the things that you must know about pendulum. So, what is a simple pendulum? When a string which is inextensible, once weight is hanged, it should not expand, right? When an inextensible string, which has almost negligible mass, right, is hanged through a metallic bob. Okay, and once this arrangement is hanged through a ceiling, it is called simple pendulum. So it's written here, the first para, right? Just read it. What is it? You can underline in your textbook or you write it in your notebook. What is a simple pendulum? A simple pendulum is a heavy point mass known as ball suspended from a rigid support by a massless and inextensible. Okay. So that is a simple pendulum. Sometimes they will ask you what is simple pendulum, right? Now, there is something called as compound pendulum. So having understood what a simple pendulum is, right? Let's understand what is compound pendulum. So it is a pendulum which is clocks. So in clocks, what do you have? Where the pendulum is hanged about horizontal axis. Right? Not ceiling. Ceiling is like this is the floor in which it is hanged. Here it is hanged on a horizontal axis. Let us say you have some nail and here it is tied. And now it is hanging on both sides of the nail. This is horizontal, like it's not the ceiling, but some nail, and the pendulum is swinging on either side. Okay, so this is all this. Rest everything is same, right? So now we have to find out the time period of the compound pendulum. So time period of a calculate pendulum. How will we calculate? Experiment. For that, we will take readings. So we'll have serial number 1, 2, 3, 4, 5, 6. Right. So we'll have the length of the pendulum, length in centimeter. So 5 centimeter. Right. Then we'll have 6 centimeter. Then we have square. We'll have 25 centimeter, not 5, 25 centimeter. Then we'll have 36. So it is 5 square, 6 square, 7 square, 49, right? Then 8 squared is 64 centimeter. Then 9 squared is 81 centimeter. 10 squared is 100 centimeter. So when we have pendulums of this length, so 25 centimeter will be roughly this length. Okay. And what we are doing is we are setting it into oscillations. So how to find the time period? Now let us say I put it in oscillation. So from, let's say I set it from this side, right? So when it goes from here, this is 1, 2, 3. So like that, I see the stopwatch. So I start my stopwatch and I start from here. 1, 2, 3. Okay. Like that, I note the time for 20 oscillations. So time for 20 oscillations. 20 oscillations. Why time for 20 oscillations? And I will call this as T second. Because it is difficult to measure just for one, right? So that if let us say clock has a division, right? Like this, 1, 2, 3, 4. In one oscillation, if say the clock pointer is here only, then it is not able to measure it. So for 20, it will go on tick, 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 tick. Yeah? So we will measure that time and then divide the total time by 20 to get the time for oscillation. Got it? So see what time we are getting. We are getting, this is experimentally found 20 seconds. Next we are getting as 24 seconds, right? Then so on and so forth. The last one we are getting is, what are we getting? What is the last time? So this is 40. Okay, 40 seconds. So is it increasing by 4? 28. Plus 4, 28, plus 4, 32, plus 4, 36. 36. And next 4 is 40. This is experiment. When you do the experiment, you will get this data. So to calculate time period, now time period will be for every observation. You have taken 6 readings. This will be T divided by 20. Right? Time period is time for one oscillation. So you will get 1 second. This you will get how much? 24 by 20 is how much? 1.2, right? 1.2 second. 1.4 second. So these times are all in second. We have already written them. Okay. What about this? 1.6. There it is 1.8. There it is 2. So now we are getting some pattern. What pattern is there? Yeah, what is the pattern? See the first and last value. Yeah. When the length is 4 times, the time is doubled. So time period of the pendulum is dependent on the length. There is a relation. How? What is the relation now? So time depends on the square root of length, or t square is proportional to length. Okay, this is how it is. So when the length becomes 4 times, time becomes double. Square root of 4 is 2. Okay, this is the relationship we have found. Right? Oh, so are you writing on this? You have written already? So we measure time with the help of the relationship that we discovered experimentally, that time depends on the length of the pendulum. Right? Now, what we will do is, so we'll calculate L by T square. So what this gives us is, this gives us T square by L is equal to constant. This is what it is, isn't it? When this comes here, so T square by L is constant. Whenever you remove proportionality, you'll get constant. Right? So how you get it is, okay, let's do the next step. That is T square equal to constant times L. Whenever you remove the proportionality, you put a constant. Therefore, T square by L is equal to constant. As well as also L by T square is also equal to constant. Okay? So whenever you have something versus something as constant, when you plot a graph, say this graph, what is the graph? Graph of T square versus L must be a straight line. Whenever you have a constant relation there between any two physical quantity, you must get a straight line graph, right? So draw this graph T square versus L, and you must get a straight line like this. Okay. And how much is this constant? That is also calculated in this table for the given experimental data. Right? So when I add one more row over here, so what will you get? You already have T, you have L, right? So T square by L. What is T? 1. 1 square by 25. Right? Is it T square by L or L by T square? L by T square. Here we have L by T square. L is 25 divided by 1 square. This will be 25. What next? 36 divided by 1 0.44, right? This also nearly comes to be 25. You can verify this. All these values will be 25. Here, L by 2 square, 4. That will be 25. Okay? But we will plot a graph T square by L. We are doing it for a reason, because what is the slope now? Slope is calculated by taking any two values on the graph. You know how to calculate slope? So slope of any graph is, you just take any 2 points on the straight line and then project over here. Okay, project on respective x and y axis. So this value is L. So this will be first value of L. This is the second value of L. So at this L, what is the time? T1 square. Here you will get T2 square. Got it? Basically, you could have taken L as L1 as 25. Then you could have taken L2 as 64. But if you want to take any values in between, then this is the technique. For any value of L1, corresponding is the projection of the y-axis. For any value L2, any random value in between, okay? This is how you get it. So what is slope? Slope is calculated like this. Slope is the rate of change of this value with respect to change in x value. Right? Slope is, what is slope? Change in y-axis. Change in y-axis divided by corresponding change in x-axis. This is the definition of slope in mathematics. So slope is equal to this y2 minus y1 divided by t2 minus divided by x2 minus x1. This is the general definition of slope. But what is the y2, y1 here? That is slope is equal to T2. Here, what is T2? It is squared minus T1 squared divided by L2 squared, L2 minus L1. Okay, so slope of the graph gives this value. It will become clear in a minute why we are doing all this. Basically, we want to be able to calculate time, right? But one dependency of time we have found out. It is on length of the pendulum. There is another dependency which is on gravity at that place, right? So this slope is found to be equal to 4 pi square upon g. This is the constant. Okay. So how do we find gravity therefore? So from any value, this will give me some number, some value of the data as it is evident. So I will get slope. And that is found to be always equal to 4 pi square upon g. This is the formula we have. So how do we get g therefore? Therefore, g is equal to 4 pi square divided by slope of t square versus L graph. Am I right? Is it correct? Yes. Okay, what is this slope? This is slope of t square versus L graph. So graphically, I can find out what is the value of slope. Whatever is the value of slope, I will substitute in this formula. Okay, why are we saying this? This is experimental. Somebody has found it, right? Now we are using this experiment. Right? But when we check it, what is 4 pi square by g? It should be roughly 25. It should be g by 4 pi square because this is L by t square, right? So what is 1 by 25? 0.4. See, it's coming to be 4. Right? That's what we were expecting. So this value is coming to be equal to 4, right? That's what we have. Okay. So which is correct? So this value is in centimeter, right? We have taken centimeter. If we convert this in meter, it will be 0.25. So 1 by 0.25 will be 4. That's what we are getting. Okay. So this is correct. Okay. So why we did all this? We need this graph of t square versus L to calculate the value of gravity at any given. This needed to calculate value of G acceleration at any place. Get it? Right? So what relation did we get now? Numerator we have time period square. So T depends on the square root of G. Right? So what is the formula for time period of a pendulum now? So therefore, the formula for time period of the pendulum. This relation gives what? This relation gives T is describe it like this. T is inversely proportional to G. And here we had got T is proportional to square root of L. Right? So when you combine these two dependencies, T is proportional to L and T is inversely proportional to G. Therefore, the formula for time period of pendulum unit is E is equal to pi L by G. To remove it, we get E square equal to 4 pi square by G So this constant, this is the constant. What is this constant? 4 pi square by g. This constant. It is g square versus L. That constant is 4 pi square by g. Got it? So we get this constant graphically. Okay. Right. So how? Just by calculating the slope. Is it clear? Are you like, okay, let it sink in, just go through what I have, what we take 2 minutes. This, what we have measured is the time period of the pendulum. That's this chapter about measurement of time. Which time? Time period of the pendulum. We have derived full theory from. Started with the experiment like that. Then we found this relation. Like when length doubles, I mean when length becomes 4 times, time period doubles. That mathematically is written like this: T square is proportional to L. So therefore T must be equal to some constant and L, right? So what is this constant? This constant will be equal to T square by L, which mathematically tells me that when I plot a graph of T square versus L, then I must get a straight line. The slope of straight line is constant. If you take any 2 point, you will always get this value, 4 pi square by. Always, right? And how much is this value equal to? This is almost equal to 4. So when we take the reciprocal of this in meter, this when I take in meter, I'll get 4. Okay, so everything is justifying each other. So now my slope must be equal to this. So what is G then? If I want to calculate G, so I know what is 4 pi square. I found slope from the graph. When I substitute here, I can calculate the value of gravity at any given place, right? Got it? So then what relation am I getting? If I write it over here, so constant is what? 4 pi square by G. Constant is what? 4 pi square by G. So when I simplify this, L goes up, 4 pi comes here. When I take this square root, then I get this formula. Okay. So when I get this formula, this is constant. Therefore, T is directly proportional to root L. And it is inversely proportional to root G. This is how time depends on L and G. Is it depending upon mass? Is it depending upon mass of the bob? No. So whether you have a bigger bob or a smaller bob, time period will not change. It will only change length of the pendulum changes or the gravity and the geography changes. Right? So at a given location, G remains constant. So only variable is L. Gravity will change when you change the location of experiment. Say you go to pole. Pole is the place you have maximum gravity. And on equator you have minimum gravity. Okay? So you'll learn about all this if you take science in higher classes, like 11 onwards, you'll learn about it. This is it. So now factors affecting the time period of a simple pendulum. Only two factors affect the time period: length and gravity. Length directly as a square root, gravity inversely as a square root. Okay. So this is mentioned as first and second point. Right? Factors affecting the time period of the pendulum is only L and G. Time period of oscillation does not depend on the mass, right? And it also does not depend on amplitude. So if there is any question about mass and amplitude, there is no sign of M or A coming. Okay? This is it. Last topic is something called as second pendulum. Are you noting it down? Have you noted? Can I erase it? Last is second pendulum. Seconds. Second pendulum is a pendulum whose time period is 2 seconds. Okay. It is a pendulum with time period of 2 seconds. What does this mean? What does this
Takes 1 second and go that way 1 next week.
mean? Yes. It takes 1 second to swing one way, another 1 second to come back to the original position. Okay. So that's how it is. So when the clock does like this, tap, 1 second, tap, tap, tap. Every tug is 1 second. Okay, so with this, we are through with chapter 1. A very heavy chapter. It has come to an end. Now the chapters going forward are going to be pretty simpler because this was quite heavy. So we'll take some numericals after few minutes. So just go through what we have covered today in this part and see if you have anything which you want me to explain. Did you understand it? From this, how we got this? From this is the definition of slope, which is change in y-axis divided by change in x-axis. How we got this from here? Because y means it is every value on the y-axis is square of time. Okay, so this is the first value corresponding to first length, right? So x1. So x1 is t1 on time, t1 square. The x1 and y1 is t1 square. x2 is l2 and y2 is t2 square. These are different values on y-axis. Okay, so y2 is final value, final minus initial. Here it is final minus initial. This is how a slope is calculated. Okay. Shall we take up numericals? So answer the question by looking at the formula. When the length of the pendulum increases, what happens to its time period? You have to see the formula. Where is the length, in numerator or denominator? Numerator. So when the value in numerator increases, the answer will be more. So T is the answer of whatever happens to the right side. With increase in length, T will increase. Isn't it? So when time period increases, it takes more time to complete one oscillation. So the clock slows down. Got it? Increase of time period means clock is slowing down. Yeah. So in winter, the length increases or decreases in winter? Winter it will contract. Right? When it is summer, it will expand. That's why the clock in summer goes slow and in winter it goes fast. The pendulum clock. Right? That's how it is. Sure. Do these numericals. We have some 7, 8, 9 numericals. Let's do the first one. One or two students absent. They are from different school. Same school. On vacation or something. Are you able to do it? A simple pendulum completes 40 oscillations in 1 minute. So what is its frequency? Frequency is number of oscillation in 1 second. So you have to find out how many oscillation in 1 second. So in 1 minute, that is in 60 second, 40 oscillations. In 1 second, 40 by 60. Right? So you have 60 seconds is equal to 40 oscillations. Therefore, 1 second is in 1 second. In 1 second, you have 40 by 60 oscillations. These are the number of oscillations in 1 second. Therefore, F is equal to 4 by 6 hertz. Find out how much is this. This is 2 by 3. Right? 2 by 3 is how much? This is equal to 0.6. 6666 like that. This will be 0.67 hertz. Right? Okay. So hertz or per second, because this is 1 by t. F is 1 by t. T is measured in seconds. So or per second. Both are unit of frequency. So F is equal to this. Now, what do you have to find next?
Time period.
So time period. Time period is reciprocal of frequency. Because F is 1 by t, therefore t is 1 by n. Right? So what is F was 2 by 3, so it will be 3 by 2 by 3. 2 by 3 little more off. Right? This will be 1.5 seconds. Okay. So questions are simple, but first time you may take time to do. Next, time period of a simple pendulum is 2 seconds. What is its frequency? So time period is given to find the frequency. So F will be 1 by t. So 1 by 2, which is 0.5. Okay. So what is this frequency? 0.5%. So what name is given to such a pendulum? Seconds pendulum, because seconds pendulum has time period of 2 seconds, right? So the special name is seconds pendulum. Third, you try. What is question 3?
A second pendulum is taken to a place where acceleration due to gravity falls to 1/4. How is the time period of pendulum if at all? Give reason what will be its impact.
Right. So time period depends on 2 things, length and gravity. But nothing is given about length, so length is constant. Right?
Yes.
So So how is time period given? T is equal to 2 pi root L by G. So let's say this is T1. Okay? And now at another place, T2 is equal to 2 pi root L by G2. Now what is G2 given as? But G2 is equal to G1 by 4, right? 1/4, right?
Yes.
This is given. What is G2? So G2 is 1/4 the gravity of the first place. So now find out. So compare. So therefore, T1 T2 upon T1 is equal to 2 pi root L by G2 into 2 pi L by G. Correct? Isn't it?
Yes.
This is how it is. When you divide, you'll get it like this. Okay, so 2 pi gets cancelled. L also will get cancelled. So we have T2 is equal to G1 upon G2 times T1. T1 goes that side. But what is T1? It is a seconds pendulum. So T1 is 2 seconds. This is equal to G1. And what is G2? G1 upon 4. Into 4 ऊपर आ जाएगा. And यहाँ पे 2. T1 is 2. Because G2 is G1 upon 4. So G1 upon 4 will go into numerator. So G1 gets cancelled. Root 4 is 2 into 2. You get 4 seconds. Okay, so what was the question and what we found? A seconds pendulum is taken to a place where the acceleration due to gravity falls to 1/4. So that we got. How is the time period of the pendulum affected? It becomes 4 times. Matlab, it becomes double. Right? The time period increases, it is doubled. Because original T1 was 2 seconds. Now it is 2 times 2 seconds. So it is doubled. Right? Why it is doubled? Because of variation in gravity. L is constant. Okay. Are you with me or no? It gets doubled due to variation in gravity. Right? So gravity is reducing. So it is in the denominator. When the denominator becomes small, the time period will increase. Okay. All right. Next, find the length of a seconds pendulum at a place where G is equal to 10 meter per second square and phi you have to take as 3.14. So this is simple. You have to find the length. So which formula you will use? There is only one formula. T is equal to 2 pi root L by G. Next one is that. So from that last formula, so since T is equal to 2 pi root L by G, you square both sides, you'll have T square equal to 4 pi square. Root will disappear. So L will be, therefore L is equal to T square G divided by 4 pi square. Okay. So what do you find the length of the seconds pendulum? For seconds pendulum, time period will be 2 square. G you have to take as 10. divided by 4 into, you have to take 3.14. Okay, so when you solve it, you should get the answer 1.014. This will go is equal to 10 divided by 0.14 into 3.1. So this is almost equal to 10, right? So the answer should be 1 point something, and that's what we did. This is 1.01428. Okay, next question. Compare the time period of two pendulums of length 1 meter and 9 meter. So you have to remember two relations for all this comparison question. T is proportional to square root of L and T is proportional to 1 upon square root of G. These two relations, using this, you can solve various questions. So find out. So there are two lengths, 1 meter and 9 meters. So therefore T1 is equal to so when you remove the proportional, it will be constant. What is it? 1 meter. And T2 is equal to constant 9. Okay. So when you take the comparison, what it will be?
-2, 3.
So therefore T1 by T2. 1 by 9. This is equal to 1 by 3. 1 is to 3. Two oscillations in 5 seconds. What is its time period? These are 10 seconds questions, right? So if you know the definitions, you will be able to do. What is the time period? Time taken to complete one oscillation. Two oscillation in 5 seconds. So one oscillation is 2.5. 5 by 2. Length कैसे निकलेगा? Same formula. Previous question.
A is equal to 2 and 2 by under.
So L is equal to T square G by 4 pi square. G is given to you. And T you found out in part A. T is 2.5. Part A, what did you find? 2.5 second, right? So that is T square. So T, but the 2.5 square into 9.8 divided by 4 pi square. That will be L. Just verify it will be 1.55. before today, we had taken only 2 lectures or 3. Sure. Only 2, no? Okay. So this 2 plus 3, 5 hours we complete today, right? Okay. So did you do 6?
Yes.
Correct. 7th row. So time periods of 2 simple pendulums at a place are in the ratio 2:1. Means L1 upon L2, but T1 upon T2 is 2:1. So T1 upon T2 is 2/1, right? What will be ratio of their lengths? देखो, this you have to use. So there is a direct dependency. So you can get T1 upon T2 is equal to root of L1 upon L2. Square both sides, so you will get L1 upon L2 is equal to T1 upon T2 also. The substitute the value of time period, so this is equal to 1/2 whole square. 1:4. अच्छा 2:1 दिया ना, 2:1. So this will be 4:2. So question 8. Interesting. It takes 0.2 seconds for a pendulum to move from mean position to one end. What is the time period of the pendulum? So how will you do it? देखो. So what is one oscillation? One oscillation is going to one end, then from this end to other end, then coming back to the mean position. So it depends what is one oscillation. So how you are counting? If you are counting the oscillation from here itself, 1, 2, 3, like this. So there are, it is divided into 4 parts. 1, 2, 3, 4, right? Or you can count it like this. If the oscillation is counted from here, then it is mean position is here, right? 1, 2, 3, 4. Okay, so 4 periods, 4 parts of the period has to be accommodated. So this is how much? 0.2, 0.2, 0.2, 0.2, 0.2, 4 times. So for a second pendulum, right?
1 second.
1 second, right? Because it is half. Wow. Okay. So we are done with the first chapter completely. Right? So just see if you have any questions left. If you have any questions left in this chapter, right from the beginning till here. If not, I'll just introduce motioning one time. Okay. I'll introduce motioning one time. That's all. Yes, any doubts? Sure. So now we'll schedule a test for you. Okay. So get used to taking tests at very short notice. Okay. So be ready all the time. Now next is motion in one dimension. So what is motion in one dimension? Any idea what is one dimension? So one dimension is along a straight line. Any straight line, either this way, this way, this way, or top to bottom, bottom to up. These are all one dimension. Okay. So that is linear motion. Motion in a line. Linear motion is motion in a line. Or and then straight line. Okay. So is it clear? So one dimension is motion in a straight line. What is two dimension? Motion in two straight line. How? Motion in a plane, right? So what is a one dimensional object? Say wire, thin wire. It has only length, no breadth, very thin breadth. So it is negligible, right? So this is a one dimensional object. What is two dimension? This is two dimension. It has a plane. The page. Page has a breadth as well as length. Okay? So any plane sheet or a plane is a two dimension. Then this mobile, it has a depth also. So it has length, breadth, and height. Okay, so anything in the space is three dimensional. For example, this duster, it is a three dimensional. It has a length, it has a breadth, it also has height. Okay. So which motion is in three dimension? The aerial motion. So when a plane is taking off, it is leaving from Mumbai, then it is going to Jammu, right? So if you look point to point, it is straight line, but it goes like this, then flies, and then also it is at some height. Okay, so then it is motion is in a space, three dimensional. So we are learning the simplest motion in a straight line. Okay. So to learn these motion, we need to have some clarity on scalar and vector objects and vector objects. Right? So in the first chapter, we learned about various physical quantities, right? So what are the physical quantities we learned? So we had some fundamental quantities, some derived quantities. So what are the quantities we learned? So let's say length, mass, time. Okay. Then we had force, right? Velocity, acceleration. Okay. So length can be called as distance also. Distance. So these are two set of quantities. This, and this. Okay, can be explained only with magnitude, as magnitude. Okay, all such quantities which can be expressed with magnitude only. Like if I say 10 meter, right, 15 meter, I can specify the length. For mass, I can say like whatever 5 kg. And a time I can say 20 seconds, etc. just a value is sufficient. Whereas in these quantities, it has value, magnitude as well as direction. It has magnitude as well as magnitude. As well as direction. So these quantities are called vector quantities. Like force, you will say 50 Newton towards east. So you have to specify the magnitude, how much force, and in what direction. Without direction, you can't specify force. You say 10 Newton force is acting. Where? In which direction? So you have to specify direction. So like that. So temperature, is it a scalar or vector quantity? Do we say it is 25 degrees in this direction? We just specify the value. So temperature is scalar quantity. Right? So is it clear what is scalar and vector quantities? Now let us specify what is distance and displacement, right? Our concept of rest and motion. First we do concept of when the body is said to be at rest, when it is said to be in motion. Concept of when do we say that the body is at rest? Are you at rest? Am I at rest? What is happening with me and with you? Hmm? You are going too far. No movement. So movement से क्या होता है? Change of position. When your position is not changing with respect to your surrounding, you are at rest. Right? So a body is said to be at rest. Said be at rest when its position does not change with respect to its surrounding. Body is said to be at rest when its position does not change with respect to its surrounding. Right? Then you have concept of motion. Its position changes with respect to its surrounding. Right? Body is said to be in motion. Position changes with respect to its figure. So we have a couple of more minutes, right? So there is a concept of how do we differentiate motion of one body with some other body. For that, we have defined certain terms, right? So there is something called as distance. Right? So let's say a motion takes place between two positions. Let's say this position is A, this position B. Then let us say a body travels like this. Like this. This is the actual path. Okay. So distance is the length of this path. Is the actual path length. Okay. In the initial, so A is called initial position. It's the initial. Is initial. Is final position. Okay. So what does it say? Student is right. This is the difference. But if the body travels from A to B directly like this, like let's say flew in a plane. It went to B directly. How can it reach to B directly? When it continues to travel in the same direction from A to right. So the shortest distance between A and B in a specific direction, that is called displacement. What is it? Displacement. It is the shortest distance initial final points. Yeah. Event direction, a specific direction. There is a direction. So therefore displacement is a vector quantity. Even its unit is meter. Unit is meter. But it is a vector quantity. Whereas this is a scalar quantity. So today I think we'll stop here, right? This is the first lecture in May. Okay, so with this, we have finished the first chapter and started the next one. All right. So you have this book, right, at home. So try attempting all the questions, the solved one as well. Okay. And we have only done the numerical, but also try answering all the MCQs, rest of the theory questions. Right. Ask me if you have any difficulty in the next. Okay, I'll see you in the next section.